Hi there and welcome back to Triplicate. And before we get started on today's project, a bit of channel news. We now have over 100 subscribers, thank you all, which means we can have a proper URL, which is nice. And on the subject of the channel, again, my apologies for being really rubbish at replying to your comments. I say in my defence, I have had problems with YouTube hanging up when I try to submit them, but I am going to make a big effort to keep on top of them and reply to all of you who leave interesting comments. Okay, next thing is, I have noticed that the lighting hasn't always been of the best on the videos, the ones that have used the camera a lot. So I have made some lights and I will show them to you. And there they are. 4 MR16, just LED spotlights, 12 volts, on the top of stands made out of bits of wood that I had lying around and into little sockets that were cheap off eBay, and bent bits of aluminium to adjust the angle. So shall we turn them on? There we go. Now they're not supposed to point straight into the camera, so shall we put the camera back in its normal position? Okay, and hopefully that should be better. And I expect the most improvement to be when I'm working on stuff on the desk. So we shall see that in a little while. Okay, I plan to get about a video a week out, but the past month I haven't managed that anything like, because we were away for nearly a fortnight on the boat and then we were visiting family, and I've been doing one of the synthesizer tutorial videos which seemed to take quite a long time. So I thought I would, just to get another video up, do a quick one, and one that I've been meaning to do for a little while now. And here it is. See, don't move that nearer the camera. So we have a twin decked cordless phone. The main one on the base station lives downstairs and that's working fine, and this is the one that lives up here, so I don't have to go charging down the stairs when the phone rings. And this has a fault, and we sort of almost did what you normally do, almost naturally in these circumstances, and just look straight on Amazon and say, oh, £25 for a new one, we'll bin it and get a new one. But trying to reduce the amount of electronics that's thrown in landfill unnecessarily, so I'm going to go have a look at this one and see if we can fix this handset. So without further ado, let's get stuck in. Right, so another innovation I'm trying. I put 4 bits of, should I say, tape at the 4 corners of the area the camera can see, so hopefully that'll stop me picking it up and working out of shot. So here we go. Now it works off AAA batteries, rechargeables, so come out. There we go. So we're done with them. Yeah, here we are, 2 good batteries, charged up batteries, and that one goes in that way and that one goes in that way, and nothing happens, which is strange because as I remember, it did come on. Hold that down. Nope, sanity check round the back. Test the voltage. It's going in 1.855 volts. So those are two completely charged up batteries. Right, so I guess we need to get in there. So there are two little slots there. Would they possibly be the way in? Because I can see no screws. Unless there are screws down those holes. No, there aren't. These holes here. No screws in the bottom of the battery case, battery compartment. So that's all I can see. Right, well, we've got nothing to lose. Right, I'm going to get a magnifying glass and have a look round and see if I can spot how you get it apart. Okay, can't see any obvious way you're supposed to do it. So we're going to do it this way. There's nothing there. Right. Let's stop myself. The screwdriver. Look at this side. Off. Change this up. See. See how it's put together. Right, flip to the one end. Which end I don't know. Of course. Yeah. Success! Oh, not too many plastic tabs dropped out. Oh, come on. And there we go. We're in. And that bit comes straight off. Display. So it feels like all that should lift out. Somehow the ringer or something on the back there. Does that flip out? Tab there. Ah. Is it? The battery terminals holding us in. Yes. Gotcha. There we go. Oh, I see. So that can go back down, and it isn't going to, I don't think. It's broken it. Broken it! Alright. Okay, so here it is apart. I've done a little bit of digging, and anyway, that with the QR code on the top, don't know what it is. It's, I guess, the phone chip just does everything. That is a 16-bit megabit memory chip, where I guess is where all your phone numbers and whatever are stored. And more interesting to us, I'm guessing that big electrolytic is across the supply. That looks like it ought to be an inductor. That, if you look at it under a microscope, has a couple of bars at the end, so I'm guessing it's a diode. And that says WJ5 on it, and googling that I found a directory of surface mount component markings. I think that is a linear voltage regulator. Now because it's dead, I suspect there's a power supply problem. The power isn't getting from the battery terminals to the main circuit. So what I propose to do is check round this power supply circuit and see if we can come to any conclusions. For which, come on, turn on, we need the meter in volts, and we need to put the batteries in. This may be a problem. Let's see if these batteries are going to stay in the battery holders. I want to put them in the right way as well. That would help. So that goes that way. Now what I propose to do is put a piece of paper or something there to stop the batteries resting on the circuitry. Okay, here we have it, one insulator, and the batteries go, I know, I just looked at it once, that way, and I'm out that way. Let me just see if anything's getting hot. Doesn't look like it. So, firstly, have we got anything across this electrolytic? .1 volts. What have we got? 1.8 volts. .8 volts across the batteries. That shouldn't be right. There should be 2 point something or other, 4 or something. So 0.9 across that one, 0.9 across that one. So either these batteries aren't any good, or something is somewhere is drawing a lot of current. Right, so I've done a bit of digging about and testing on this, and I have concluded the capacitor is not across the supply, or it might be across the output. Well, firstly, the thing isn't going to run off 2.4 volts. It has this wireless system for talking to the base station, so it's got a voltage regulator, a boost voltage regulator, and these two components I guess are part of it. Unfortunately I can't find a chip. Normally switch mode voltage regulators have chips associated with them, but it is connected to that transistor, and I think that's a transistor. Might be a chip, but I'm just looking up the code on the top of it, the 3-character code, but I can't remember. There we go. So that, the positive, is connected to one end of the inductor, and there's a diode there, which you also get around switch mode supplies. Now, I've no circuit, you can't get a circuit, so I'm guessing, but that is an electrolytic capacitor, and they are the cause of a high proportion of failure of electronic equipment. They fail, and if I put this back now, no, the meters, no, that's in diode, in ordinary mode, if we look at this, then it's showing 60 ohms across there, which seems to me to be a bit little, a bit small. So what I propose to do is attempt to get the soldering iron and pull one side of this capacitor up so I can test the capacitor on its own without whatever it's connected across. Okay, here we go. You see, I've taped her down to the bench. Stop it running away. There we go. We'll just run some solder onto there. Stick the screwdriver onto there, hopefully. Can I just pull it? I might have to pull it off completely. Whoops. It's not playing. Okay, I've got a scalpel under it, so hopefully I'll solder on the iron. This is off the problem with surface mount stuff. Once you try to work on it, all you do is break it. Aha. Ah, come on. And nobody asked you for your opinion. No, I don't have a rework station. Got ya. And even if I did, it probably would be the end of the capacitor once I tried attacking it with that. Come on. burnt plastic on the iron bit. There we go, and it's got tracks all the way along underneath, so it's alright when it goes through a reflow oven and everything's heated up to solder melting temperature, but trying to get it off is a pain. Right, we've got it off. Negative to the left as we're looking at it, and you should have seen most of that even. Right, negative to the left. We're in standard ohms mode. Come on. That is not being conclusive. Well, that should have put some volts across it. I'm just trying to measure whether it's holding any sort of charge. Yeah. Yeah, it's gradually discharging, but it's holding charge alright. So, it would appear that this is actually alright. So we're reasonably happy the capacitor is good. What about the inductor? So I'm going to have to zoom you out, always the wrong way, a little bit so you can see the meter. Now I reckon the inductor is between there and there. These pads run all along one edge. So for instance, if I put that one probe there and one probe there, dig dig dig, it goes down to nothing. However, if I put one of those there and the other one there, I get absolutely nothing. And if I probe across those two corners again, I get nothing. So there is no current going through that inductor. Now it could be that the inductor, something went wrong, and when it was drawing a lot of current it burnt the inductor out, but the inductor doesn't look burnt. Now that pad's going to come off. So I am going to take the iron, in it, and at least dab some solder on these two corners. Because if you look under the microscope you can see the wire coming out of the corner there and onto the pad, and you never know, it might have come off or the connection might be bad. So we are going to try and put plenty of solder, move the meter, on each of these corners. And meter out again. Zoom you out. Goodness, went the right way. And shall we see what we get across here? So we're looking for, I don't know, 100 ohms tops. Still nothing. So, do we reckon that inductor is not happening? Okay, so I was just off camera having a little poke around at that inductor to see if I could see what the problem was, and it broke. It came apart in my hands, governor, honest. So that certainly isn't going to work. Now whether I did that while I was poking around, but I was poking very gently, so I suspect maybe the handset had got dropped and it had just sheared. I do recall that when things got dropped 10 feet out of machine cabs on the concrete, it was the inductors that broke and fell off the boards. So unfortunately I have looked at the top with the microscope and there is nothing written on it. Maybe there's something written on the bottom. So I shall endeavour to get what remains of it off. Because at this point we've really got nothing to lose, because we don't know what it is, we can't get a replacement really. Guess a value, I suppose, but yeah. So, okay, let's get the iron out. Well, there it is. It's the main body of the inductor, and these are the two pads, both of which are broken away from it. It is possible I broke the first side trying to lever it up, but I do not believe that to be the case. Now, I only pulled at it very gently with the end of a scalpel and it came up. So I am going to call that the reason it failed. So sadly, I think I'm going to have to call that one a fail. Now, you can't win them all. A victim of electronic products that are so cheap it's cheaper to replace them than repair them, and a victim of surface mount components that don't have anything written on them, so you've no idea what they are, so you can't replace them when they do fail. Anyway, it's been an interesting little investigation into what goes into cordless phones, so I think on that note we're going to leave it for this one. Subscribe, comments, thumbs up, be nice. And for now it's goodbye from Triplicate, home of interesting electronics. Goodbye.